So this week we're learning about mole dimensional analysis or mole conversions, where you go from one unit into another unit. So the problem, you're going to start with the problem on your worksheet. It's already written down. How many grams of lithium are in 4.6 moles of lithium? So I need to, let's say I have 4.6 moles of lithium, I need to figure out what that's going to weigh in mass. So I'm converting from one unit into another. So the rules, number one is you always list the number and the unit you were given first. Okay, so read through the question, what number and unit were you given to start with, and you write that down. So we were given 4.6 moles of lithium. This is the number we were given. So you're going to write this down in that space on the top of your notes worksheet, 4.6 moles of lithium. Then you're going to do a conversion. So when you do a conversion, you're going to draw a division bar just to the right of that. So it should look like this, 4.6 moles of lithium with a line after that. And then you're going to list the units that you were given on the bottom, okay? And we're hoping to cancel these units. That's why they go on the bottom, because they're going to be divided by. So units you were given on the bottom. So moles of lithium is the unit I was given, and so I'm going to write moles of lithium on the bottom. So starting unit here goes on the bottom. Next step is to list the units you are solving for on the top of the division bar. So whatever they asked you for, the unit, that goes on the top. So they asked for grams of lithium, and so I'm going to put that on the top here, grams of lithium. Now to fill in the space. So this you're just going to have to know. It's only 3 things, so it's not too hard. So moles are the base conversion factor. Everything goes through moles, and so wherever you have moles, you write 1. So when we're talking about conversions, we're talking about how many things are in a mole, how many grams are in a mole, how many atoms are in a mole. Mole, you always go through mole. So mole is the base conversion factor, so you're going to write 1. Where it says grams, you have to go to the periodic table for that element, and you're going to get its mass. For this week, we're just going to do elemental mass. We won't do molar mass yet. So molar mass would be like if you have H2O, you have to multiply the mass of H times 2 and add that into O. You did that a little while ago. So we will do that starting next week, but this week we'll just do elemental mass. So you just get the mass off the periodic table. And then wherever it says atoms, you're going to write the mole, which is 6.02 times 10 to the 23rd. So there are 6.02 times 10 to the 23rd atoms in 1 mole. And so moles you write 1, grams you write the mass, atoms you write the mole number. Alright, so then that brings us to our problem here. On the top I have grams. So what do I write for grams? I write the mass. So I go to the periodic table and I look up lithium and I find its mass. And then down here it's moles, and mole you always just write 1. So it's going to be 6.94. This came from the periodic table, and this 1 is always what you write with the mole. And then you're going to solve it. So remember, you multiply by the numerator, which is the top number, and then you divide by the denominator, which is the bottom number, and then you round your answer to the correct number of sig figs. Actually, we're not doing sig figs right now, so you don't have to do that, which is, good for you, because significant figures can be hard for people. So we'll not do sig figs. Round it to whatever you want, as long as you round correctly. So you have 4.6 moles of lithium, and so your front unit, when you divide, is going to cancel your bottom unit. So moles goes away, which is what I wanted. And then I'm going to take my 4.6 and I'm going to multiply by the top number and then divide by the bottom number. So 4.6 times 6.94 and then divide by 1. And so the answer you get is 31.924. If you were doing sig figs, you'd have to round this to 32, but we're not going to do that. So, round this however you want. You could do 31.9, you could do 31.92, you could do 31.924, whatever you want to do is fine with me. We won't do significant figures right now. And so then the next thing is to make sure you include units. So with units, it's always going to be the top unit, the one that's left on the top of the last division bar. And so your first unit here, moles, canceled, and so that leaves you with grams. This should also be the unit that they asked you for, which in the question they asked for grams of lithium. So you got 31.924 and then grams of lithium. These should match each other. Don't forget your units. That is very important. So here on the second page of your notes, you have one of each kind of dimensional analysis problem here. So for this one, you have grams. They give you 42 grams of Na, which is sodium, and they asked for moles. So here we're going to convert from grams to moles. So I'm going to do this with my drawing tool. You can type if you want, but I find the drawing tool is a little bit easier to work with. So you're always going to start rule number 1 with writing what you were given, okay, in the problem, including the units. So I'm going to write 42 grams of Na. Okay, that is step 1. Okay, write what you were given. Draw your division bar. Okay, take your starting unit and put it on the bottom. Okay, so this is going to be G of Na down here on the bottom. The top unit is going to be what they asked for, and so they asked for moles. The abbreviation for mole is MOL, even though it's only chopping off one letter, the E, but you write moles in a problem as MOL. That's how you abbreviate it. And then it's moles of Na. Alright, now you gotta go to those things you gotta remember. So moles of Na, remember you write a 1 in front of mole. Mole always goes with 1. For grams, you're going to go to the periodic table to get grams. Grams comes from the periodic table. So I come here, I come into my periodic table. If we all use the same periodic table, we'll all get the same answers. So sodium here is 22.99. So I go back here and I put 22.99, okay, for its mass. Now that that's filled out, I can go ahead and solve. So when you are dividing by dimensional analysis, the front unit will cancel the bottom unit, and this will go away, leaving me with just moles, which is what I want. I take my calculator, I put in 42, and I divide that by 22.99, and that gives me this number here. And again, you can round to wherever you want. There are rules about rounding. That's called sig figs, but we're not going to do that right now. So round wherever you want, as long as you round correctly. So this will give me 1.8, let's round here, 1.83. And then moles of Na. Make sure you include a unit on your answers. Very important. Alright, so that is how you go from grams to moles. Here in the second problem, you're going from moles to, it says weigh, and so mass would be weigh, and that would be grams. So we start by writing what we have, 2.18, okay, and then moles. And then it's Cu. You draw your division bar. You take your front unit, you put it on the bottom. So all this goes on the bottom. Moles of Cu. On the top, you're going to put what they asked you for, which in this case was weigh, which would be mass. So we weigh things in grams, and this would be grams of Cu. And the mole, you're going to write 1. Okay? And with grams, you're going to go to the periodic table. So Cu is right here, 63.55. And then you solve. So I go to my calculator, and I do 2.18 times 63.55, and then I get 138.539. And again, you can round this to wherever you want. So I'm going to do 138.5. And you could write the 539 if you want. Alright, and then the last thing to do is units. So remember, your front unit cancels your bottom unit. When you divide, those are going to cancel. That's going to leave you with the top unit, and that's what you should write here, grams of Cu. Units are very important when doing dimensional analysis. Alright, this time we're going to go to atoms. So again, start by writing what you have, and you were given 7.2 moles of chlorine, and chlorine is Cl. And then you draw your division bar, you take your starting unit and you put it on the bottom, and then you put the unit that they asked you for on the top, and in this case they asked for atoms, so this would be atoms. Oh, sorry, I put Where's my eraser? I put Cu. There we go. Cl. And this would also be Cl. Alright, wherever it says moles, you put 1. Wherever it says atoms, you put the mole, which is 6.02 times 10 to the 23rd. Alright, and then you solve. So I've got 7.2 and 6.02 is on top, and I multiply by the top. And so I'm going to multiply 7.2 times 6.02. So let me go to my calculator. 7.2 times 6.02 is 43.344. So let's do 43.3. Right? Now, I got this 10 to the 23rd. You're going to take this 10 to the 23rd and you're going to bring it over and you're just going to drop it there, times 10 to the 23rd. And when you're working with numbers in scientific notation, you need to make sure that the answer that you get is in correct scientific notation. Remember, correct scientific notation is a number between 1 and 10, and this is not. So 43 here is not going to work. So you need to move the decimal. I'm going to move it one space over to the left, and this is going to be 4.33 times 10 to the 24th. Okay? Do not forget, left goes up, right goes down. So left, up. 24. Now the last thing I need to do is units. So I have moles of Cl here in front. I'm going to cancel that with moles of Cl down here on the bottom. And then I have atoms of Cl here, and I'm going to drop that off as my unit. Atom of Cl. So make sure your scientific notation is in correct scientific notation. One more. So here you are given atoms and you are solving for moles, so the backwards of what we just did. So you're going to start with 1.3, always write what you have, times 10 to the 27th, and then the unit is going to be atoms. Alright, and they didn't say what element this is, they just said atoms and moles, and it doesn't matter when you're converting between atoms and moles because you don't need to use the periodic table. So you don't need to look up the specific element, so don't worry about it if they didn't include that, but you're going from atoms to moles. And then mole, so atoms on the bottom, and then what they asked for is moles, and that goes on the top. And then wherever you have mole, you have 1, and atoms, you have 6.02 times 10 to the 23rd. Okay, now we solve. So when you have a number on the bottom, you're going to divide. So 1.3 divided by 6.02. So put that into your calculator, 1.3 divided by 6.02. And that gives you that number there. So I'm going to do 0.216. So this equals 0.216. But don't forget your exponents. So 10 to the 27th here and 10 to the 23rd here. And remember, you do top minus bottom. So this would be 27 minus 23. Okay, and so this would give me 0.216 times 10 to the 4th. But wait, you're not done. So you check your base number. Is it a number between 1 and 10? And here it's not. So I do need to move the decimal over 1, making this 2.16. And then I moved the decimal to the right. Remember, right means down. So this becomes 10 to the 3rd. And then I'm not done yet. I still need units. So my atoms here canceled. And then the top unit here is mole. So do not forget your units anytime you're doing dimensional analysis, because that's the whole point, is to know what unit and then convert that into that unit. So this would be your answer here. So these are the 4 different kinds of dimensional analysis problems that you are going to be asked to do this week. So I gave you an example of each one.